Continuing with our revision, now we go to parallelograms and we start with the properties that we need to recall. Both pairs of opposite sides are parallel, both pairs of opposite sides are equal, and both pairs of opposite angles are equal, and diagonals of a parallelogram bisect each other. Based on the knowledge of parallelograms and parallel lines that we have, then we can be able to solve these exercises. Number one, the first thing that you need to know for number one, all the problems that are listed under number one, A, B, C, D is given to be a parallelogram. So parallelograms have opposite angles, both pairs of opposite angles equal, both pairs of opposite sides are equal, and also both pairs of opposite sides are parallel. So I can just indicate here that I know that this side is equal to that one. That means AD and CB are equal, and they are also parallel. And also DC is parallel to AB, and also DC is equal to AB. Once I've indicated that, then we can be able to solve. Remember, we're just asked for the unknowns. All in all here, we are asked to determine the value for G. But then where do we start? We start with the fact that the angle that we have is found in the small triangle on the side. Angle E is 30 degrees. So we need to determine which other angle is equal to 30 degrees. But then, before we move any further, we have this triangle ECD that we have to consider. Based on the fact that we had concluded that AD and BC are equal, so it means for this triangle we have an isosceles triangle. If you have an isosceles triangle, it means two sides equal, yielding to the fact that the base angles are also equal. So that means this angle is also 30 degrees. So angle CBE is 30 degrees, equal to angle E, because they are base angles of an isosceles triangle. Okay, because we know that we have been given that CE is equal to DA, and we know that DA is equal to CB because opposite sides of a parallelogram are equal and parallel. So DA equal to CE equal to CB. So now that we have this 30 degrees, we can be able to determine angle ABC using angles on a straight line. We can use angles on a straight line, so that means 180 minus 30 degrees will give us that angle to be 150 degrees. So angle ABC is equal to 150 degrees, and therefore because opposite angles of a parallelogram are equal, then we are able to say that G is also equal to 150 degrees. We go to B. Remember, A, B, C, D is a parallelogram. So starting from there, I know that AB is equal to DC, right? And is also parallel. So DC and AB are equal and parallel. Okay, and then also AD and BC are equal and also parallel. So with all that information, recall that we've been given that AB is equal to AE is equal to BE. This means that this is an equilateral triangle because it's got three sides equal. So therefore, I know that angle AEB and angle ABE and angle EAB, they are all equal. Their value is 60 degrees. All of them are equal to 60. So how will this help me? 60 here, and all these angles are 60 degrees. So I have 60 here as well. And I'm just writing down the angles, that they are all equal to 60 degrees. Do not mind my mouse that doesn't write properly. So if I've got now angle EBA to be equal to 60 degrees, then that means I can be able to find that angle inside the parallelogram, which is ABC, angles on a straight line. So if this angle is 60 degrees, angle EBA plus angle ABC, they're equal to 180 degrees, angles on a straight line. So that means I can be able to find angle ABC to be 180 minus 60 degrees. That means that is 120 degrees. So if it is 120 degrees, what is one of the properties that we have for a parallelogram? Simply says opposite angles of a parallelogram are equal. So that means H is also equal to 120 degrees. For this example, we have AC, a diagonal of a parallelogram. I'll start there. And the parallelogram is ABCD. So the first thing I do is to remember the properties of a parallelogram, that it's got two opposite sides equal and parallel. So that means those sides that I've indicated, they are parallel and equal. That's the first thing, so that I know what I have and I know what I need to establish during the calculations. So AD is equal to BC, and they are also parallel. DC equal to AB, they are also parallel. DE has been given to be equal to BF, as AD has been produced to E, and CB has been produced to F. And these two intersect at the point X, that is EF and AC intersect at X, And then we are asked to prove that AXE, triangle AXE, so this is the triangle that I'm dealing with, AXE and triangle CXF. So that's the big triangle that we're looking into. Now, first things first, I have alternate angles here because I've been given AC is a diagonal for the parallelogram. So I've got alternate angles, but these two alternate angles that I've indicated, they are outside the triangles that I'm looking into. So I have also D, or should I say EAX, or I would just simply say DAX is equal to angle XCF. They are alternate angles because of AD parallel to BC. Because those two lines are parallel, I have those alternate angles, and they are in both triangles. So the first thing I have is that angle EAX is equal to angle XCF, alternate angles because of AD parallel to BC. Next up, I've got vertical opposite angles. Angle EXA is equal to angle CXF, vertically opposite angles. And then lastly, I have AD equal to BC and also DE equal to FB. So all in all, line AE is equal to line FC. So I can say these two triangles are congruent because of angle, angle, and a side. Then we're supposed to prove that AFCE is a parallelogram. AFCE is a parallelogram. Now, using the congruency in A, remember I have two angles that are equal. Angle EAX equal to angle XCF, and also angle EXA and angle CXF, they're equal. And we had said that these two triangles are congruent, therefore angle E, which is angle AEF, is equal to angle CFX. And those two being equal because of the congruency, then according to AFCE, we see that they are alternate angles because of the diagonal EF. Therefore, we can say AFCE is a parallelogram. By just proving the congruency in A, then it leads us to the equality of those two angles, which are alternating as per the parallelogram properties. Then we move on to the rectangle and the rhombus, starting with the definition as well as properties. A rectangle is a parallelogram. Note first, A rectangle is a parallelogram, so that means it's got both pairs of sides equal and parallel, and it's got opposite pairs of angles equal. And then on top of that, all its angles are right angles. So it has got angles that are 90 degrees. Secondly, the diagonals are equal. It's got an added property from that of an ordinary parallelogram. The angles are right angles as well as the diagonals that are equal. Then we come to a rhombus. The rhombus is also a parallelogram, but it has all its sides equal. The first thing that pops up into my mind when we're talking about all sides being equal is a square. It's a parallelogram. Opposite pairs of sides are equal and parallel. Opposite angles are equal. And now we've got all sides, all four sides being equal. Now we've got the second part, which says the diagonals of a rhombus bisect each other at right angles, and they bisect the angles. Right. So let's do some examples and some exercises based on these definitions and these properties. First one, supposed to determine the unknowns. That's the main objective, bearing in mind the properties of the rhombus and the rectangle, as well as the properties of parallelograms. Why here? This is a square, of course, the rhombus. That means we've got parallel sides, all sides equal. Note that because it's a parallelogram, so that's the first thing that we have to indicate. Parallel sides and equality. For equality, all the sides are equal for a rhombus. Now it means that we can be able to find angle B. B is also 40 degrees, alternate angles. And what about angle A? For a rhombus, the sides, the angles are 90 degrees. So if we've got 90 degrees here, that means A is 50. And what about C? The diagonals, they bisect at right angles. So that means C is 90 degrees. We go to B. This is a rectangle looking at its shape. So that means it's also a parallelogram. Let's continue to indicate that. Parallelogram, and the opposite sides are equal. And we're going to use this property to determine the value for A and B. A rectangle has got 90 degrees as angles. At their vertices, at its vertices. So only with 112 degrees, what can we do to calculate the values for A and B? Only with 112 degrees there. So if this is 112, that means that is also 112. But how is it going to help? We have 90 degrees and we've got 90 degrees. We don't know those two angles, A and B. Please continue with this problem and solve for the values of A and B. Please make sure you state your reasons. We're given a parallelogram and we're supposed to look for the values of A, B, and C. So I'll just quickly indicate once again so that whatever happens, I'm able to identify what I have and what I do not have, and what I can use and assist me in the solution for the given angles. We're given 65 degrees, given 30 here, and we've given 42, and we're supposed to calculate A, B, and C. It would help to also label your parallelogram. We've got A, B, C, and D. And then if you've got 42 degrees, let's say I have here X or O, whichever letter you choose to use. B, A, C is 42. And I'm looking for the value for A because of those parallel lines, AB and DC, then that means A is also 42. If A is 42, that means that whole angle is 72 degrees. And if I've got 72 degrees there and 65 there, then that means it will be easy for me to calculate that angle. All right? But then how is that going to assist me with finding the value for B? Here, we have a triangle DXC, and A is 42, XDC is 65, then we can be able to calculate the value for that angle. And if we know the value for that angle, we use vertically opposite angles so that we can be able to calculate the value for B. And if we know B, then we're sorted. Then we need to calculate C. We need to get back to the big triangle BDC. Remember, A is 42, so that means that whole angle is 72. We've got 65 there, 72. We can then be able to calculate the value for the angle DBC. And if we know DBC, it will give us the value for C using AD parallel to BC. Therefore, DBC is alternate to C because of AD parallel to BC. Please work this out and get the values. Then we've got some theorems and corollaries that we need to recall. Opposite angles of a cyclic quad are supplementary. Exterior angle of a cyclic quad is equal to the interior opposite angle. The angle between a tangent and the radius drawn to the point of contact is a right angle. Two tangents drawn to a circle from the same point are equal in length. The angle between a tangent and the chord drawn to this point of contact is equal to the angle in the alternate segment. The line segment joining the center of a circle to the midpoint of a chord is perpendicular to the chord. The perpendicular bisector of a chord passes through the center of the circle. The angle which an arc of a circle subtends to the center at the center is double the angle it subtends at any point in the circumference. The last ones, the angle subtended at the circumference of a circle by a diameter is a right angle. The angles in the same segment of a circle are equal. Angles subtended by equal chords in the same circle are equal, and angles subtended by equal chords in different circles with equal radii are equal. Based on all these 12 theorems and their corollaries, let's do some exercises. Firstly, O is the center of the circle. Determine angle Z. Let's start there. These two angles, angle W and angle Z, are angles that are subtended by the same arc. Therefore, they are equal. So angle Z is 72 degrees. Also, O1 is twice the angle at the circumference, which is 72. So therefore, O1 is 144 degrees. That means we've already solved angle X, O, Y, which is O1 in this case. Now we're asked to find W, Y, Z. W, Y, Z, that angle. Note that angle WXZ and angle WYZ are angles that are subtended by the same arc. So angle WXZ equal to 30 degrees yields XYZ to also be equal to 30 degrees because they are both subtended by the same arc. For a second example, X is the center for the second circle, P is the center for the first circle, and you've got angle DAC, angle DAC. So that's the angle that we have there. I'll indicate